please notice right now, I just want you to see that there's a difference between 9 and 10. Okay? Get to know those parent functions. An exponential function here, there's a couple things we need to know. Know that the exponential functions have horizontal asymptotes. Okay? So if I'm going to draw a quick sketch of these, it's like this. That's what they look like. Horizontal asymptote. Okay? So then down here, when you see these, it's the inverse of that. So if I just told you this one is going to be like this, okay, then this one has to be like that, because it's going to be the inverse of that one, and it has a vertical asymptote. So that's a talk you got to kind of know before you attack these problems. So with that said, here we go. This one is going to move, and this is just knowing kind of what they do. This is going to move left 1, and this 2 here is moving it up 2. So left 2, up 1. So from the origin, this is very hard to see, so I'm going to put an X there. Okay, there's where I'm assuming my origin is. The graph isn't the greatest on this video. So I'm going to go left 2 and up 1. I'm sorry, left 1, up 2. So left 1, up 2. There's my new origin right there. Okay, so now my origin is no longer here. It's right up there for this problem. Okay, so now I'm going to do my 3 key points from there. Okay, but before I do so, I'm hopefully knowing that this is the horizontal asymptote for this problem, because that's what all exponential functions do. So y equals 2 is my horizontal asymptote. Okay, so moving along here, I couldn't help myself. All right, so here, left 1, up 2, key points. Key points are all based off of, and I'll do these over here, off of just the parent of base 3 raised to the x power. So the 3 key points, the first one I always did was 0. 3 to the 0 power, anything to the 0 power is 1. So that's my first key point. From that new origin, there it is, 0, 1. And then here we have putting in a 1. Well, 3 to the first, anything to the first power is just itself, so we get a 3 there. So from there, I'm going to go right 1, up 1, 2, and I'm going to go make a point there. And then the last key point is putting in a negative 1. It's not the last one I could do, but these are the ones we've kind of talked about. So negative 1 is 3 to the negative first power, which we know is 1/3. So negative 1 up 1/3 right there. And then I take out my, oh, sorry about it. This is challenging. There we go. And I do a quick sketch there. Okay, but make sure you get those 3 key points. We will be looking for those. So the domain of these exponentials is all real numbers, of course. And then the range is actually starting here at my asymptote, and it's above the graph for this one, 2 to infinity. All right, so how's this one different? This next one here, okay? Let's go in red. Looking here, what does this tell you now? Right 2. So from the origin, which is clear here, I'm going to go right 2, and I'm going to put an X, okay? I'm not shifting up, down anywhere, so I actually have a horizontal asymptote right through that spot, which is just the x-axis. So we have the equation of that, which is y equals 0. All right, my key points now for this one are based on e to the x. All right, well, same deal. Put in a 0, you get a 1. Nothing changes there. So that point's going to be on the graph. What happens if you put in a 1? You get e. And e, we know, is approximately 2.7. So from here, I go right 1, up 1, 2.7. Give myself a nice dot. And then negative 1, 1 over e. Okay, which we've been talking about is approximately 1/3. So left 1 up, 1/3. Hard to show there. But then I connect them, and I have myself my exponential function shifted right 2 with a base of e. So the domain is still negative infinity to infinity for that, and then the range is from the horizontal asymptote up, 0 to infinity. Okay, so now let's talk about these. If you understood that stuff, now we're talking about the inverse of the exponential, which is the logarithmic. So this one's got kind of a lot going on here. We're going to shift left 1, watch the pen there, left 1 and down 4. So left 1, down 1, 2, 3, 4. There's my x. Since this here is a logarithmic one, like we said, we now have a vertical asymptote right there, vertical asymptote. All right, so where are my key points coming from? Well, this has a base of e. Okay, I guess I should say this right now. I am not going to talk about this 2 until the very end. That 2 is dealing with a vertical stretch. Okay, I'm not going to deal with that till the very end of the problem. Okay, So right now I'm left 1, I'm down 4, and I'm thinking, this is how I do it. I think of the exponential function with base e, because that's the inverse of what we're looking at right now. And if you remember from what we just did, 0, 1 was a key point, 1e was a key point, and then negative 1, 1 over e is a key point. But I don't want those. I want the inverse of those, right? So what we do is we flip them. So this becomes 1, 0, e1, and then 1 over e comma negative 1. And that represents the key points that I'm now going to graph from this origin. So from here I'm going to go right 1, up or down none. I'm going to go right e, 1, 2.7, up 1. Wait. I have to go up twice as far as I normally did. Now that didn't matter here, but it is going to matter here. So remember, we have a vertical stretch of 2. So normally I go right 1, 2.7, up 1. Now I have to go up 2. That's all that vertical stretch does, is it just stretches it to do twice as much vertically. And right here, look at that. Normally I go right like 1/3 down 1. Now I'm going down 2. That's all. So I connect, and I got myself my logarithmic function there. Okay. I'm not as good as remembering to do these right away, so I'll try. X equals negative 1. Okay, we knew that was going to be shifting left 1. The domain here is no longer all real numbers. It starts at negative 1 and goes on to infinity, left to right, and then the range this time has all real numbers. Okay? All right, moving on. One more. So what's this last one do here? If you're looking at this one right here, what's the negative do? Not a stretch, but it's just going to flip our graph. Okay? Flip vertically. So anything that's up is down, and was down was up. Okay? So it's going to flip it vertically. And then nothing left, right, but down 2. So that one is down. Okay? So what's that going to mean? We're going to go down 2. So down 2, here we go. There's my new origin now. And this might not show up the greatest, or I might not sketch it the best, but there's a vertical asymptote there. So there's actually an asymptote at x equals 0 for that. All right, well now let's plot some points. Well again, I can look right up here. I don't have to like write them out again. These are my key points for a logarithmic function with base e. So from that new spot, I'm going to graph them. Okay, I'm going to plot them. Just keeping in mind that I have to flip stuff. Okay, so when I do this one, I always like to graph that one first. I go right 1, up or down 0. Flipped is not going to matter. Okay, but this one, normally I'm going to go right 1, 2.7, up 1. Now I'm going to go down 1. That's all. So instead of up 1, I'm going to go down 1. I don't know what just happened. Let's reboot here. There we go. Green, thank you. So right 1, 2.7, and down 1 instead of up 1. All right, and then this one here, right 1/3, down 1. Well, now I'm going to go up 1. So right 1/3, down 1 becomes up 1, and that would be right there. And what's that going to do? Change colors here to try to capture those green points still. It's going to kind of go like that. Okay? Well, what happens to my domain and range? By flipping, nothing really. The domain is still going to start at 0 and go on to infinity, and then the range will be all real numbers. All right? I really hope this helped you. I hope this made you become more like this for this information, and I hope that your studying is going well. There's extra practice in your book online. Keep trying. Checking solutions. That's the big part. Check solutions. Okay? Thanks.